Hello again. Get ready for a really insightful lab walkthrough on web APIs. Hopefully this will help cement the value of web APIs for you. Let's get started. In this lab, we are going to use the Azure Text Analytics API, and you have to sign up following these instructions here. If you're a student, you should be able to get a free account and use that free account to complete the lab. Shouldn't really cost you anything. Just follow the instructions to set it up. If you're not on campus, you have to make sure you use Remote Lab, which is the instructions are here, because you need to be in the United States in order to get access to your free Azure account. Okay? So once you get your Azure account set up, you will have what's called an endpoint, which you can see right here. That's my endpoint. And you'll also have an API key. You will need the API key and the endpoint to correctly call the API. The Azure Text Analytics API allows us to do things like named entity recognition, sentiment analysis, and key phrase extraction. So these APIs are generally used to help us find meaning in text. And we will, of course, demonstrate how to use them, but also the rationale behind why you would want to use them throughout the lab. So after you put your key and endpoint in this area here, you should be able to test out the API. And this code down here, this is before we do 1.1. This will just sort of walk you through how to run the API. So the first thing is you have to create what's called a dictionary. And that dictionary has a key called documents, and then there is a list of all of the text. So the APIs need to be efficient, and one of the ways that they do that is by not making us constantly have to go over the internet and make subsequent calls. So the Azure API allows us to build a very large document of all of the text that we would like to either perform sentiment analysis on or named entity recognition or whatever. In this case, we're doing named entity recognition. So rather than send, this one and then make another call and send this one, we can be more efficient and group all of the text we want to analyze, send that once, get that information back with one call. That's the more efficient way to do it, and that's how most of the APIs work. As a result, because we could be sending a lot of data, we are not using a GET request, we are using a POST request. See, that says POST here. So all this stuff, is in the documents. So if you were to go and look at the Azure documentation here, you would see a lot of details about how to do that. So I'm not going to get into that right here. Let's just create a third one here just for the heck of it. And this will be ID 3. And in here, let's put IST256 is the greatest course at Syracuse University. We all know that's true. So I'm building a bunch of things that I want to do for key phrase extraction. And I put this under a variable called payload. Payload is a concept that generally refers to the data that you're sending to make something work. Okay, that's considered to be the payload. So the type of payload here is in JSON format. So when we make this request, we include the URL, the headers, and the JSON payload, which is the data. So I want to point this out now because if you look over this code looks very similar to the code we've used before to call APIs. And it brings up a very important point. Calling APIs is identical. What changes is the information you give it and the method you use, but it's always the same. It's make the request and then deserialize the response. And we know this raise for status is used to just handle errors. If you get a 404, throw it so that I know that there was an error there. Okay. So this particular API requires your base endpoint plus, in addition to that base endpoint, it requires the rest of the URL to get to the service we want. So in this case, we want the version 3.0 of named entity recognition. And then I have to give it my subscription key in the header, and this is the proper format to use. This is, again, all in the instructions. And then I need to post the JSON payload, right? So this is this data up here. This is the data that I want to recognize the entities in. And the only thing that's going to change here from call to call is this payload. That's it. Everything else is 100% consistent. Without further ado, let's run it. So the response that you're going to get back from the API when it's finished is a series of documents, and that's a list. And then this is document number 1, and this corresponds to request number 1. And it finds all the significant entities in there. So this is $5, and it's considered to be a quantity of currency. How cool is that? It figures it out. And then next week is a date range. And then in the second request, it recognizes Syracuse as a location, and Rochester as a location, and Buffalo as a location. And then in the third one, it recognized Syracuse University as an organization. So how cool is that? That's named entity recognition for you. All right. Now that I've taken a little bit of time to explain sort of what's going on, we can do our 1.1 U code. And it says, rewrite the example above to perform named entity extraction on the following text. Now, we want to perform named entity extraction on this text here. So I hope at this point you realize that this 1.1 is extremely trivial, because this code here is the same code. The only thing that's going to change is the payload we give it. So we are going to say, payload. I can call it anything I want. Data. And then it needs to have documents and then a list of documents, right? So let's just do this. And then a list of documents. And that list has an ID. Let's make this ID 1. And then the text, in this case, is going to be, I'm just going to call it text. And then the variable is going to be this, right? Text is that. So let's just see what data looks like. So this is the payload that we're going to send it. In this case, we're just sending it one piece of text. That. Now, hopefully I did the payload right. It looks like it's going to be right. It looks like this ID should be in quotes. See that? So I'm going to fix that. Like that. Okay. Now that I've got the proper payload, believe it or not, the rest of the API call is the same. I'm going to go to the same endpoint. I need to use my same subscription key. I need to make the same request. I need to, check to see if there's any errors. I need to take that same response and deserialize it. All of this stuff is identical to the way it was before. This is the beauty of calling APIs. The only thing that changes is the data that you give it. Okay? Knowing what is the input and what is the output of the API makes writing multiple APIs very easy, because the guts of it are always going to be the same. Request, deserialize the response, assuming it's JSON. So I'm going to take this, copy it, go down here. Now in this case, I called it payload, but I want to use data instead, right? So it's important whenever I always say don't copy and paste code, but whenever you do copy and paste code, don't just copy and paste it and run it. Read what you wrote, right? So is this going to change? No. Still the endpoint, still going to named entity recognition. Again, that's me reading the Azure docs. This is the subscription key. This gives me the permissions to use the service. This is me actually invoking the service, and I want to send in not payload, I want to send in data. Okay, so this is actually the part that actually asks Azure to do named entity recognition. And then we all know what raise for status does. It throws an error if it's not a 200 response. And then this is the part that does the deserializing. And this turns it into a Python data structure that we can go through. So let's see what we got in here. Yesterday is a date. 4 out of 5 is a quantity. How cool is that, huh? New York City is a location. Coders are people. Wow, that's a cool one. Organization, Google is an organization, Microsoft is an organization, right? That's awesome. Doing that yourself would be incredibly difficult to do, right? But using the Azure service, all you got to do is invoke an API call and you can do it. So basically that's 1.1. Okay, let's talk 1.2. Before we go ahead and start running this code, let's just think of the big picture. When you get output like this, it's not very useful in the program, right? Okay, we see what it did, but you know, my mom's not going to know, you know, what to do with this output. So we need to be more explicit. Like, for example, and down here, what we're trying to do is extract out the location. Any named entity that's a location, we want to particularly extract that out. Okay, and this example up here does the same thing with emails. So it finds any emails in the text and extracts those out. All right, so we're going to loop. Oh, I want you to think of the strategy. We're going to, you know, boilerplate. We're going to call the response, request and response, and get the entities. Then we want to loop over the documents key because that's a list, and we want to find any entity that is of type location, where the category is location. See that? Category is location. So before we sort of get into the bottom one, let's just sort of do this. Like if I were to take, you know, and go entities, and I'll just pick one, 3, it doesn't matter. And then I get a key error because I need to go entities documents first, right? Okay, now I got a list. See that? Now I got a list. So I'll just pick one, 3. Oh, that's too far. Okay. Oh, there's just one document. Okay, and now this one has a keyed entities. And then that I can pick maybe the 3rd or 4th entity out of there. So this one is an email. Let's take a look at the second. That's an email. And maybe the 1st. That's a skill. How about 0? That's a year. So then from here, maybe I want to get the category key. See, this is the part of this part you will have to figure out for every API. The only thing that's different from one API to another API, whatever API you pick for your project, the only thing that's different is the way you call it via its endpoint, and then what you do with the response you get back. Those things are going to be unique to every different service that you're going to use, whether it's, you know, Amazon, Azure, Spotify, Yelp, whatever you want to use. That's going to be unique to that service. IBM, you know, whatever. Okay. So let's go down here and try and figure this out. So big picture, what we're doing here is we're inputting some text like nobody likes Syracuse. I like Syracuse, but I'm just throwing something in there. Okay. And we're getting some errors here. So now we need to figure out what's going on. So we get a 404 error, right? That tells us that this isn't right. The endpoint isn't right. So let's make sure our endpoint is correct. What did we use before? Text analytics 3.0. Oh, see, I have 3.0K. And you see, I'm a sneaky bastard there. I shouldn't have done that. Okay, 3.0. Okay, let's run it again. Syracuse is awesome. Okay, and I get an error. 3.0 entities recognition general. So I wonder if I'm still making a mistake somewhere. Text analytics. I think I just spelled something wrong. I'm going to copy this part of the endpoint. That looks better. Let's try it again. Mike is in Rochester. Okay. Still getting an error. It says permission denied. All right, I wonder if my API key is not right. Maybe I overwrote my API key on accident. Hang on, let me check. Well, that's a really unfair error. So it should be the variable key, not the value key. Look at that. See what I did there? Man, I didn't even recognize my own error. That's a nasty bug. I want to use the real key, not the word key. So that's why I'm getting this client error. This is, by the way, why you want to have raise for status. You want to see these errors so that you know when you're making a mistake calling the API. Okay, let me just try it. Okay, now it seems to be calling the API because it's taking longer. It's actually going out to the Azure service. Okay, so it worked now. Let's see if we can make it work. Let's run it, and let's put in Buffalo and Syracuse. Let's see if we can get some locations up here. Okay, it says key error type. So when you get a key error, what it's saying is in this variable entity, there is no key type. So the way you diagnose something like this is you really need another cell. You need to come down here and look at entity. And there's no key called type. See that? I don't see a key called type. That's why we're getting a key error. So the key what we want for location is called category. See that? Category. So what I want to do is say if entity category is location, print the entity's text. Okay, so now this should just print out the locations. Let's try it. Mount Rushmore is in South Dakota. See if two locations come up. Mount Rushmore is one location, South Dakota is another. So we finished 1.2, and let's just think about something really quickly when it comes to APIs. It's great that you can call an API and get this out, right? But unless we can extract the useful information from it, right, we can't do something additional beyond just using the API, right? We might want to use this bot to figure out where somebody is or what locations people like, right? Or maybe what foods they like, right? So you can use named entity extraction to say, oh, is this a food? And do they like it? And to do that, you need to parse through that data structure that you get back, okay? And that was really the point of 1.2. All right, here we are in 1.3, and now we are going to use a different service called key phrase extraction. Key phrase extraction. And basically, to use key phrase extraction, we're going to use a different endpoint. See this? It says text analytics 3.0 key phrases, whereas before we had Text Analytics 3.0 Entities Recognition, general. So there's different endpoints for different services, but they all use the same API key, okay? And they all use the same base endpoint, right? Which is defined in here, where you go right there, right? So they all use the same base endpoint, and they use the same API key, but the terminating endpoint recognizes what service it is. And if you go here, you can read all about it in help as to how it works, and you know, the requests and the response and things like that. So ultimately you have to read the docs in order to really understand it. But what you'll notice with this particular example, right, I have the payload set up, I have the key set up, I have the URL endpoint set up. Calling this API is exactly the same as calling these other APIs that we already did. I need to invoke the post, I need to check to see if there's an error, and I need to get the response back. I mean, this was sort of the point of 1.3, was so that you know that the cadence of invoking an API is exactly the same, right? We need a payload, we need a header, we need a base URL. The docs say to do a post. We're going to get a response. If the response is not a 200, I want to throw an error. And then I want to deserialize the JSON. Now, I'm not going to make entities this time. What I'm going to make are key phrases. So entities, I could call it entities, but to be more accurate, this should be key phrases. So let's see what we get here. All right, so we have review 1, review 2, and review 3. And we have back 3 documents, ID 1, and the key phrases are eggs. So I don't think I will ever order eggs again. So eggs was a key phrase. ID number 2, went there last Wednesday, was crowded, pancakes and eggs were spot on, enjoyed my meal. The key phrases there are pancakes, eggs, and meal. See that right there? And in ID number 3, the key phrases are place. I don't know who's running this place. And check that out. It didn't just get eggs. It got eggs Benedict. And then it got hand on the other hand. And it got toast. I was happy with my toast. Okay. That's key phrase extraction. Again, we didn't have to do much to make this work. And that is the point. Okay, that's the point I'm trying to drive home with calling APIs. You got to know what you're doing, but the actual plumbing to make it work is the same 3 lines of code every time. It's the setup that's different and the punchline that's different, right? It's like telling a joke, right? This is the setup. Where am I going on the internet? What do I need to send it in order to make it work? And what data do I want to give it as input? And then this is what you get as output. And then it becomes a matter of figuring out how to interpret the joke, right? How do I get to eggs? You know, how many documents mention eggs? Well, there's eggs here, there's eggs here, there's eggs there, right? Could I write code to figure that out? Because that's really, you know, getting this back is great. But again, this isn't mom friendly. Mom friendly would be all 3 documents mention eggs. Okay, can you do that? That's just a matter of going through lists of dictionaries, right? That's just a matter of going through lists of dictionaries, the things that we've been talking about since Unit 9. All right, 1.4 UCode. Generally, it makes sense if you can combine key phrases and sentiment together. Think about it. If you know someone has a positive sentiment, you might want to know what they're positive about. So if they're talking about eggs and it's positive, then you know they're saying something positive about eggs. This is extremely useful in brand recognition in social media. So for example, someone might put a tweet out And you might run sentiment analysis over the tweet and say, oh, this customer likes, is happy based on the tweet. It's a positive tweet. But you might want to know what in particular they're talking about. So, for instance, they might be talking about the iSchool. They send a tweet to Syracuse University, and they say, I really like the iSchool. So named entity recognition will get us the iSchool. And then the tweet, the overall text in the tweet will let us know if it's positive or negative. That's sort of the idea. So what we're going to do now is we're going to write code that does sentiment analysis over the same 3 reviews. And what you're going to notice is it's the same thing, right? I'm going to go up here. I'm going to grab this. I'm going to come down here. Ta-da! Right? My reviews here. Go into the payload. And I have my endpoint has changed from an endpoint that gives us key phrases to an endpoint that gives us sentiment. And then we have the subscription key. Again, one thing I am missing is the actual building of the payload. I probably didn't intend to forget to put that in here, by the way. Okay. I'm doing a lot of copying and pasting, but that's because I want you to see that calling any API is really the same structure of code. And I think the best way to see that is by noticing me copying code and changing like one small thing, and then boom, works. And then recognizing that these are all very similar. All right, now this time I could say key phrases, but that doesn't make a lot of sense because I'm getting sentiment out. So I'm going to change this to sentiment. And then let's take a look at that. So that first document, I don't think I will ever order the eggs again, is negative. So how powerful is that you know that it's a negative sentiment, but also it's talking about eggs? So right now I can say, well, maybe I need to get better with my eggs because customers at my restaurant don't like my eggs. All right, sentiment of ID number 2 is positive, and then sentiment of ID number 3 is mixed. Okay, there's some positive and there's some negative. So it breaks them up and says, this part was positive and the other part was negative, right? So the part that was negative, not sure who's running this place with the Eggs Benedict, we're not that great. And then the part that was positive was, on the other hand, I was happy with my toast. So this API is really robust in that it can sort of chunk up your input text into individual atomic pieces of sentiment. And you can see it probably does that based on the period. Breaks them up into sentences. Okay, so that's 1.4. And while I've got your attention, let's go down. There isn't really a 1.5. This should be labeled 1.5. It wasn't in the lab. Let's make a working program out of this where we do like what you would normally want to do with sentiment and named entity recognition, which is build either a chatbot or create some social media analytics where you get an idea of what people are saying about a certain thing. So in this case, what we're going to do is we're going to pretend we're building a chatbot where you input something that has a location in it. And we will find the location in your input and say something back to you based on your sentiment of that input. So we need to not only calculate the sentiment, but we also need to recognize the location. So we're going to have to use named entity recognition. I'm just going to put that down here. We're going to have to use the sentiment endpoint and the named entity recognition endpoint. So we're going to have to make 2 calls. to have to make 2 API calls, one with the sentiment and one for named entity recognition. And so for input, we're going to actually have you type that, right? We're going to say text equals, input, enter something about a location. And this is oddly specific, not really what you'd want out of a chat bot, but again, we're just sort of getting this thing started. And because I don't want to run this and have to type every time, I'm going to put something in like, I had the best barbecue in Memphis this summer. That's going to be my input. I'm going to take that, and I'm just going to make that my input for now until I figure it out. Right? Now, I need to build my payload. Right? And my payload looks like this, but I only have one document. Payload. This is very specific to the Azure API. The way you might build this in another API is going to be totally different. That's the good and bad of APIs, is that this information changes depending on the service you use. There, I think I built that correctly. And then I'm going to need a key and my header, or my header and my URL endpoint. That's my URL for sentiment. What's the URL for named entity extraction? That was way up here, wasn't it? There it is. I'm going to grab that. Now, since I need 2 URLs, I probably want to make different variables for each one. So I'm going to call this, sentiment URL, and this is going to be entity URL. All right. Now, let's think this through. I need to call the sentiment API. So let's do that. Let's do response requests post. I can actually copy this. It is literally this. The only difference here is that I need to change this URL from just saying URL to sentiment URL. URL, like that. Okay, and there's my header. And there's my JSON payload. Okay, and let's see if this works. Sentiment. I got a couple mistakes in here. So in here, I need to set, this is a list, and then I need to make a dictionary out of this. This is why I probably should have copied it. But, yeah, it's fine. Sometimes what helps to make this easier to figure out is you do this. You break it up into lines, right? And then you have an idea. There we go. See, now, there we go. Now it looks a little better. Okay, and I got it back. And this sentiment is positive, right? So I can see it's positive, but I need to extract that out. But we'll get to that in a sec. Okay, so that's the sentiment part. Yay. Let's call it and get the entity recognition. So it's the same code. Now I'm going to say, not sentiment URL. I'm going to call a different endpoint. I'm going to call the entity URL. And the response back, I don't want to overwrite sentiment. I'm going to call it entities. So let's see what we get here now. Calling the sentiment first, calling the entities second. And in entities, I have this location at Memphis is the location. All right, so let's now that we've got the tools, we need to figure out the rest of the algorithm. So I need to get at the sentiment positive, negative, or neutral. I need to get at the location so that I can reply back and say, how kind of you to say good things about location. Or I'll also make up a negative phrase like, I'm sorry you feel that way about location. All right? So let's figure out how can we get out the location. We want to get out this location. So again, we have to sort of walk through this structure. So what I'm going to do is while I'm figuring this out, I'm going to open up another cell down here. And let's go to entities. All right, and I need the documents key. Then I have a list, and there's just one list, so I'm just going to go 0. Then this is the first item in the payload that I sent, and there's only one item in the payload. So I can go down to entities, and then I get a list of everything extracted out. And I'm looking for the location, right? So I want to say this is where I need to loop, right? Because I don't know if this one's location or that one's location. I need to find it, right? So I have no choice but to say for, entity in that if entity category is equal to location. Now I have my location. So I'm going to say location is entity text. So if I go down here, it should say Memphis. Standard algorithmic searching. We've done this so many times, it's crazy. You loop over a collection. If you find something that matches, you set the variable to the thing that you want. And I probably want to break the minute I find it. Right? That way I don't continue to loop. So that helps me find that Memphis. Okay, so that gets the location. This is so useful, it probably should be a function, but I'm going to skip that. So this will get me the location. So I'm going to call this, extracts location from Python data structure. Now we need to extract the sentiment. So we got to do the same thing for sentiment. So come down here, sentiment. You'll see we got our documents key. Again, this is thanks to Azure, and then the first one in here because there was only one that we sent, right? And this one has a sentiment key. Positive. There we go. So this one's a heck of a lot easier to get out than getting the location. There. Now I can do my code. I can say if sentiment is equal to positive. I think it's like that, right? Let's go look. Positive, right? Then I want to say print, I am glad you feel that way about location. Else, print, what can I do to convince you that location is a great place? How's that? Make this like chat body. All right. That's it. Now I replace my text with an input, and I am good to go. Enter something about location. Syracuse is the best sports town. Cranking, 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 cranking. I'm glad you feel that way about Syracuse. See, it's like a chatbot. Let's try it again. Atlanta is too hot in the summer. Maybe that's negative? I don't know. Cranking, 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 cranking. What can I do to convince you that Atlanta is a great place? See? There you go, right? Kind of cool, right? This is the mom test, right? It's using these APIs. You don't even know it. You don't even know it's using those APIs, right? It's just doing it, right? It appears to be so intelligent, and we're standing on the backs of a cloud service to make it intelligent. So you can see how you could build a really interesting and unique chatbot using this type of approach. This is just a very simple approach. We're looking for very particular entities like locations, but you can use it to look at other things. You could use the key phrase extraction to find out what people are talking about. Like, are they talking about shopping? Are they talking about education? What is it that they're talking about when it refers to Atlanta or Syracuse University? Okay. So you can sort of get an idea of the promise of this kinds of technology. All right, that's this week's lab walkthrough. Thank you. Bye now.